Now in part C we get a new point D. So we had our triangle ABC. And now we get this point D, and I know that the vector, so let's say D is here, and this would be the vector W. So we know that the vector W, the dot product with U and the dot product with V is 0. It means that the vector W is perpendicular to AC, the vector V, and also to the vector U. And okay, so I also know something about the area of the triangle ACD. And ACD is a right triangle, since W is perpendicular to V. So I can immediately write that the area of ACD is the length of V times the length of W over 2. So this is a right triangle, so the multiplication of these two sides over 2 is the area, and this equals 5. We already know that the length of V is the square root of 11, so we can isolate for the length of W and get 10 over square root of 11. So this is one equation that I already have, and I will use two more equations, will be this and this, the fact that the vectors are perpendicular. So if I will call yet now the vector W as A, B, and C, I will also write down the vectors U and V. So U is here, and A is 0, 1, 2, and B is basically P, Q, and 3, but they say that we take the case where P was 1, and then Q is 2, and 3. So the vector AB, I simply subtract coordinate by coordinate, so it's 1 minus 0, 2 minus 1, and 3 minus 2. So the vector AB, or U, is 1, 1, 1, and in the same way the vector V will be 3, 1 minus 1. Now I'm going to use the fact that W dot U is 0, so ABC times 1, 1, 1 is 0. I get A plus B plus C is 0, and here I will take the dot between W and V, also to be 0, So it's ABC and V, which is 3, 1, minus 1. So I get 3A plus B minus C equals 0. Yeah, so if I do, let's call this equation 1 and this equation 2. So if I take equation 1 plus equation 2, then I get 4A plus 2B, C cancels out, it equals 0, and then I divide by 2, I get that 2A plus B equals 0, or that B equals negative 2A. Now if I will take 1 minus 2, yeah, equation 1 minus equation 2, I would get minus 2A, B minus B cancels out, and C minus minus C is plus C, and I get that C equals 2A. So if I add my vector W, which was A, B, C, now I can write him as A minus 2A, because B equals minus 2A, and C equals 2A, so here I have 2A. Now I'm going to use the length of this vector. So the length is A square. Let's take the length already squared, so I won't have to take the square root. So I just take coordinate by coordinate and square it. So it's A square plus 4A square plus 4A square. Sorry, so I have here a small mistakes. Now I notice it. Here I took 1 minus 2, and there I get C minus minus C, which is plus 2C. So I get actually that C equals A and not 2A, and here I also have to write it as A. So now I want the length of the vector A square plus minus 2A square plus A square. And I also know, I showed it here, that the length is 10 over the square root of 11. So the length square is 100 over 11. So from here I get that 6A square is 100 over 11, and that A square is 100 over 66. So then I will use the calculator, and I get that A equals plus minus 1.515. So B equals minus 2A. And C just equals A. Yeah, so I have so W is 1.515 minus 303 and 1.515, or W is negative 1.515 303 and negative 515. So this is the answer to 12C.